Hello everyone and welcome to this lab session. In this lab practical, we will perform sentiment analysis on Amazon product dataset. I have provided the link to download the dataset, and this is where you can download the dataset from. This is a multi-domain dataset that contains product reviews from Amazon.com, and the dataset is spread over 4 different product types, and these are kitchen, books, DVDs, and electronics. So in this section, we will use the multi-domain dataset. We see that Amazon has a large number of products that belong to different categories. Customers, after they make a purchase, also give their reviews after using the product. Reviews can either be good or bad, and for good reviews, ratings provided are high, and for bad reviews, ratings provided are low. So in future, how to determine after seeing a set of positive and negative reviews that the review provided by the user is positive or negative. So this project focuses on predicting the sentiment of the reviews by training a model on a dataset of customer reviews and testing on a part of that dataset. We will be performing the following steps to train and test our model. Let's begin by importing the necessary libraries for the project. So I'm importing the Pandas, NumPy, Matplotlib, and Seaborn libraries. Here we go, click on the run icon and the libraries are imported. So in Colab, once you start running the codes, it automatically allocates a GPU resource for the notebook. Alright, so the next thing I will do is import the dataset. For that, I have these 8 datasets. For each product, we have positive and negative reviews. My datasets are placed inside the folder on Google Drive itself. So before we can access the datasets and import them directly, we first need to import the drive from the Google Colab. So run it. And here you can see it asks for the permission to allow this notebook access to our Google Drive files. And I will allow it by clicking on the Connect to Google Drive option. Now, if you have multiple users, it will prompt and asks for the email on which you want to allow access. So here we allow our email ID. There we go. Now I can import the datasets. And when I run it, you can see that the dataset is imported with success. Let's explore each of the dataset and talk about it. First, I will show you the dataset points for negative reviews on book products. Here we go. So we have unique IDs starting with numbers, and the SN column has these numbers separated. And this is the Amazon standard identification number. Then we have the product name, followed by the product type, the helpful column, and rating for the product. Then we have the title for the product, date of review, reviewer person name, their location, and their actual review. So these are all the negative reviews for the book product. Now let's display the positive reviews for the same book product. And here are the positive reviews for the book product. In the similar way, you can do the same for other products too. I will skip it for now, and here are all the code snippets you can run on your own. So this is it for this lab session. In our next lab session, we will start from the exploratory data analysis for this dataset. Hello everyone and welcome to this lab session. In this session, we will perform the exploratory data analysis on the dataset we imported previously. So as you can see, the columns, namely unique ID, helpful, date, reviewer, reviewer location are unnecessary for us as of now because we are interested in training a model that is able to detect if the comment is positive or negative. So for this purpose, we will remove these columns from our dataset. Let's run this cell. So our columns are removed. Let's now have a look at the dataset after removing these columns. And now we can see that the columns are removed from the dataset. We are only left with the necessary fields required to train our model for sentiment analysis. Now I will concatenate all the reviews into a single file. So for that, we will first make a single data frame for all the datasets. Let's run these cells. The new shape of the dataset is 8,000 data points with 6 columns. Now I will save this data frame as a single CSV file with the name amazonreviews.csv. Next, with the help of the import files library in Google Colab, I will download this newly created CSV file. And here is the downloaded file, and we can see all the columns of our combined dataset. Next, we will go ahead and shuffle the dataset so that we have the dataset mixed up. Here is the displayed shuffled dataset for our case. Let's now perform some statistical analysis on this new dataset. Using the describe functions gives all the statistics for the numeric data in the datasets. Let's run it. Here the unnamed is the index number, so we can ignore it. The ratings here are of more importance to us as of now. So we have all the 8,000 ratings in our dataset. The mean rating is 3.05. Standard deviation is 1.72. The max value for the rating is 5. Looking at it, we can say that the dataset has all the ratings available. And the mean is also good, meaning that we have an equal number of positive and negative reviews that will be helpful for our model to be trained. Moving on next, let's have a look at the info. It shows the total count for each column and their data types as well. So we can see that the dataset is complete and we have no missing values. Then the shape of the dataset is the same. We have 8,000 data points with an additional column for the unnamed index number added, which makes it a total of 7 columns now. Now let's have a look at the unique values in each column. The unnamed 0 is not of use to us. Then we have 6,302 values unique in the SN column, 5 unique values in the product type, 4 unique values in the rating column, and so on for other columns. Now I will look at the total number of instances that we have for the positive and negative reviews. Let's run it. So you can see that for the 5-star ratings, we have 2,879 values. And for 1-star rating, we have these many values and so on for each of them. One thing to notice here is that we don't have any 3-star rating in our dataset. So now we will perform the imputation of the values. So basically what I'm doing here is change the rating values to 0 if its value is less than 3, and for the rest of the cases, the rating value will be 1. So this will differentiate between the positive and negative reviews. In short, a 0 represents negative value and a 1 represents positive value. Next, I'm adding a few features with the name word count in the dataset. This will count the number of words in the review text and display its count in this feature column. Now let's plot the average number of words in the positive and negative reviews. Here we go. So it's almost equal. Positive review text word count is a little bit more than the negative ones. We have already evaluated that there is no missing value in the dataset, but there is also a function in Python that you must know, which checks for the missing value in the dataset. This .isNull function will look for it. Let's run it. And here you go. All sums equals to 0. Now the final part before we do the data cleaning is to split the test and training dataset. This I will do with the help of sklearn library. Basically, I will split 30% of the dataset to test data and the remaining 70% to training dataset. So here this cell will display the train and test datasets. This is it for this lab session. In our next lab session, we will start with the data cleaning part and then the model training part. Hello and welcome to this lab session. In this lesson, we will clean our data to train the model that we are looking for. So first, I will be importing the natural language processing toolkits. Then download the WordNet library, and it is a lexical database for the English language. You can use WordNet alongside the NLTK module to find the meanings of words, synonyms, antonyms, and more. Then download the stop words. The stop words in NLTK are the most common words in data. They are words that you do not want to use to describe the topic of your content. They are predefined and cannot be removed. Next, we have the punct, which is a tokenizer, and it divides a text into a list of sentences by using an unsupervised algorithm to build a model for abbreviation words, collocations, and words that start sentences. Then I have a few more necessary libraries to import. Import the inflect library. It correctly generates plurals, singular nouns, ordinals, indefinite articles, and convert numbers to words. Then we import the WordNet lemmatizers. Lemmatization in NLTK is the algorithmic process of finding the lemma of a word depending on its meaning and context. Lemmatization usually refers to the morphological analysis of words, which aims to remove inflectional endings. Next, we have the word tokenize module, which is imported from the NLTK library. Word tokenize is a function in Python that splits a given sentence into words using the NLTK library. Then I will import the Jenisim library. It is a leading and a state-of-the-art package for processing texts and working with word vector models. Alright, so here I have declared a text pre-processing function. The purpose of this function is to remove the emoji texts from the reviews, convert the entire text to a common lowercase format, and remove any emails from the text, remove the digits, any alphanumeric value in the text, extra white spaces, as all of these can lead to word incorrect model training. So let's run it to initialize the function. Now we will use this function to pre-process the train and the test datasets. And now let's check the word count after pre-processing. So obviously the number of words will reduce as all the extra and irrelevant words are now removed from the texts. Now to have a look at percentile value for the new word counts, let's see at the numbers for train and the test datasets. So here we have the different percentile values for the test and the train dataset. Alright, so this is it for this lab session. We will start from defining a model and training it to be used in our next lab session. Hello everyone and welcome to this lab session. In this lesson, we will define a model and train it. So the first thing I'm going to do here is separate the target value and the feature value for both the test and training dataset. So Y-train here will contain the target values of the dataset, which is the ratings, and the X-train will contain the features of this dataset. And here same goes for the test dataset as well. Next, we will do the tokenization. Tokenization is the process of breaking up a string into tokens. Commonly, these tokens are words, numbers, and punctuation. So in line number 3, we have assigned the number of words to be 10,000. These are the maximum number of words to keep based on word frequency. Then we call the method fit on text with review text as an argument. The fitOnText method is a part of Keras tokenizer class, which is used to update the internal vocabulary for the text list. Next, we use the text-to-sequence function to create a new feature with the name text_tok, short for tokenized. This transforms each text in text-to-sequence of integer. So it basically takes each word in the text and replaces it with its corresponding integer value from the word index dictionary. Let's run it. Now we perform the padding and the truncating. So for that, we import the sequence library and setting the maximum review length to 1500. This will pad the sequences to the same length. So if I just show you the values inside the X train pad, you can see here that we have an array of numbers for the tokenized values. Now we will use the globe vector. It is a global vector for word representations and is a supervised learning algorithm for obtaining vector representations for words. So first I will import the globe vector that I have saved in my Google Drive. Next, we will create some embedding metrics and vocabulary from this globe vector. And here next, we assign these padded values to the test and training variables. Let's run it. Now we are moving towards the model definition. So here the input layer to the model is our review text, which I have named as a review input. Then we have the embedding layer. It turns positive integer indexes into dense vectors of fixed size. And this is mainly used in natural language processing related applications such as topic modeling, but it can also be used with other tasks that involve neural networks. So while dealing with NLP problems, we can use pre-trained word embeddings such as globe. Always remember that the embedding layer enables us to convert each word into a fixed length vector of defined size. So the resultant vector is a dense one with real values instead of just zeros and ones. The fixed length of word vectors helps us to represent words in a better way along with reduced dimensions. Now that we know we are using the long short-term memory, that is LSTM network, here we have declared the bidirectional LSTM with 100 layers. Next, the dropout layer is set. So dropout is a technique used to prevent a model from overfitting. And dropout works by randomly setting the outgoing edges of hidden units to 0 at each update of the training phase. So the dropout rate is set to 0.5 for this case, at which the input fraction will be dropped. Then we have the flatten layer, and the role of the flatten layer in Keras is very simple. A flatten operation on a tensor reshapes a tensor to have the shape that is equal to the number of elements contained in tensor, non-including the batch dimension. Next, we have 3 dense layers here. And the dense layer is a neural network layer that is connected deeply, which means each neuron in the dense layer receives input from all the neurons of its previous layer. So the dense layer is the most commonly used layer in the models. And in the background, the dense layer performs a matrix vector multiplication. So here the first dense layer has 64 outputs, the second one has 8, and the last one, which is the final one, has 1 output. The activation function is relu for the first and second dense layer. And then for the final dense layer, we have the activation function as sigmoid. So finally, we declare the model and print the model summary. So here you can see that we have the model summary printed. You can also plot the model to have a visual of the created model. And here we have the models visually displayed. So we have the review input layer, then the embedding layer, followed by the bidirectional LSTM, then the dropout layer with flatten and dense layers. So now let's move ahead and start the model training. Our model training has now started, and the model training will take some time, so I will pause the video here and we will start evaluating the model from the next session. Hello everyone and welcome to this lab session. In this session, we will evaluate the model that we trained in our previous lab session. Before we begin with evaluating the model, the first thing we need to do is save the model and upload it in a known path on Google Drive. As we are using Google Colab, so it is required to provide a complete path of the model. Let's see how you can do it. First, I will run this line to save my model with the Amazon Review Model Skill Curve version 2 and in the H5 format. And here you can see that this file is being downloaded to my PC. Now I will save the model to the Google Drive. And here you can see my model is uploaded. Next, we will load the model from the saved location. So here I have provided its path. Let's proceed and evaluate the model. This cell here will make the predictions on the X-test dataset, and we will round the answers. So let's run this cell. And here we have the predictions. Next, I will calculate the accuracy of the model and print it. Great, the accuracy for our model is 81%. Let's also have a look at the confusion matrix. So a confusion matrix is a table that is used to define the performance of a classification algorithm. And it visualizes and summarizes the performance of a classification algorithm. So the model did a total of 2400 predictions, and out of these cases, the model predicted yes 1210 times and predicted no 1190 times. In reality, 1191 are positive reviews and 1209 are negative reviews. This purely justifies our 80+ accuracy on our test set. This is it for this lab session. In our next lab session, we will look at how you can deploy this model, and then on entering the text, the model replies with the review type. Either it is negative or positive.